Quantum and neuromorphic computing, the future of AI and beyond. What if the next generation of computers doesn't just calculate like machines, but thinks like a human brain or taps into the strange world of quantum physics? Welcome to the Christian Omeni Tech Channel, your trusted hub for cutting-edge tech insights, smart solutions, and future-forward innovation. If you're passionate about technology and want to stay ahead of the curve, you're in the right place. Subscribe now and join a growing community of thinkers, builders, and tech enthusiasts. Fresh content drops regularly. Don't miss out. So we dive in. 1. The battle for the future. Quantum versus neuromorphic. Imagine a world where quantum computers crack problems that would take supercomputers thousands of years, in seconds. And neuromorphic chips run AI so efficiently that your smartphone mimics the thinking pattern of your brain, consuming almost zero energy. Sounds futuristic? It's not. Both are real, both are advancing fast, and both may define the future of AI and computing. 2. What is quantum computing, and why does it matter? Traditional computers use bits, 0 or 1. Quantum computers use qubits, 0 and 1 at the same time, thanks to superposition. This means they can process massive parallel computations simultaneously. They harness entanglement, allowing linked qubits to share information instantly. Real-world impact. A drug discovery, simulating molecules for new medicines. A financial modeling, predicting market behaviors with insane accuracy. A cryptography, breaking encryption, or creating unbreakable ones. Companies leading the charge are IBM Quantum, Google Sycamore, D-Wave, IonQ. Google claimed quantum supremacy in 2019, performing in 200 seconds what would take the world's fastest supercomputer 10,000 years. 3. What is neuromorphic computing? While quantum computing is about physics, neuromorphic computing is about biology. It mimics the human brain. It uses neurons and synapses in hardware instead of traditional transistors. Chips like Intel's Loihi and IBM's TrueNorth simulate how neurons fire, adapt, and learn. Benefits. Ultra-low power consumption, perfect for edge AI. Real-time learning without the cloud. Brain-like adaptability for robotics, self-driving cars, and IoT. 4. Show real demos. Quantum in action. IBM's Quantum Experience lets you run quantum algorithms in the cloud, today. Neuromorphic in action. Intel's Loihi can recognize gestures using a fraction of the energy of GPUs. Startups like BrainChip use neuromorphic AI for vision in drones and autonomous vehicles. 5. How do they compare? Quantum, best for complex simulations, cryptography, and optimization problems. Neuromorphic, best for AI at the edge, robotics, and ultra-low power applications. Think of it this way. Quantum equals Einstein on steroids, solving mind-bending math. Neuromorphic equals brain in a chip, adaptive, efficient intelligence. 6. Future predictions. By 2030, Gartner predicts 25% of enterprises will adopt quantum solutions for logistics and security. Neuromorphic chips will be in smartphones, AR glasses, and IoT devices by the late 2020s. Expect AI running on neuromorphic chips for real-time language translation without internet. Quantum AI hybrids, combining quantum algorithms with neuromorphic-inspired architectures for superintelligent systems. 7. Why should you care? Because your job, your business, and your devices will be impacted. Cybersecurity. Quantum will break old encryption. Companies must upgrade. AI at the edge. Your car, your medical devices, even your smart fridge will think like you. New careers. Quantum engineers, neuromorphic AI developers, hybrid system architects will dominate the job market. 8. Make it relatable. Your Netflix recommendations? Today, cloud AI. Tomorrow, neuromorphic chip on your TV. Online banking. Today, RSA encryption. Tomorrow, quantum-safe cryptography. Gaming. Imagine real-time physics simulation on quantum-powered servers. Zero lag, ultra-realistic worlds. 9. Challenges. Quantum needs cryogenic cooling, error correction, and massive investment. Neuromorphic, still early, hard to program, limited ecosystem. But remember, so was AI in 2010, and look where we are today. If this future excites you, don't just watch it happen, be part of it. Learn quantum programming, Qiskit, or neuromorphic development, Loihi SDK, now. I hope this video has been informative for you, and I will like to thank you for viewing. Please subscribe to our YouTube channel for more content.